2.8, we're talking about something called functions. And I'm sure you've heard of functions before, but a function is basically this set of values or ordered pairs, or it could be an equation where it takes an input and then gives you a corresponding output. So input, we typically think of x, that's like the independent variable, and then the output would be like y, that's like the dependent variable. So in general, a relation is just a set of data, right? So it could be a table, it could be a graph, like you could get a line, or you could get a parabola, right, if it's quadratic. You could get a list of points. It could be a mapping diagram. There's a lot of different ways to, list a set of points or even draw a line. So that's what a relation is, just a set of data. And then a function is a relation. So again, we're taking this data, but this data is not allowed to have any x values repeated, okay? If there's any x values that are repeated, it is not a function, okay? We don't care about the y values. The y values can repeat or not repeat. It doesn't even matter. But if the x values repeat, then it is not a function. So if I go to these examples here, we'll start with a relation. These are just lists of points. So if I look at my x values, let me get to this color over here. We see that we've got 2, 6, -2, and 5. So all we have to do here is if we want to know, is this a function, we're going to say yes, because no repeated x values. All right, so this would be a function. We can go to the next one. We've got, let's see, we've got -3, 2, -9, -9, and 3, but I see an issue, right? I see that we've actually got this -9 happening 2 times. All right, so because the x values do repeat here, we're going to say, no, this is not a function because the x values repeat. All right, they repeat here and here. We got 2 -9, so this would be a no. All right, now I'm taking the same set of data and I'm putting it in tables. So a table is just another way to express or to kind of show this relationship. So you can see I've got the same x values, right? 2, 6, -2, 5. 2, 6, -2, 5. So I have all the same data here. I just presented it in a different manner, so just kind of getting a different perspective there. But again, these are going to be the same answer, so this will be yes. Again, if you look at your x values, none of the x values are repeated, so that's a yes. And if I look at the other one, we can see that my x values, -9, repeat twice, so this is going to be a no. All right, so again, you have relations, which are just a list of ordered pairs inside braces. Remember, these symbols are called braces. So braces at the start, braces at the end, and then you just list the ordered pairs in between. That's called a relation. Table is when you list the ordered pairs either vertically or horizontally, doesn't matter, and you show the data that way in terms of x and y. And then you have what's called a mapping diagram. So I'm again taking the same information that we've been using and I'm putting them into these mapping diagrams here and here. So in the first mapping diagram, the way that you do this is you draw from an x value to a y value. So I see in the first point here, we've got 2, -3. So I'm going to draw an arrow from the 2 to the -3. Then I see that I have 6, 1. So I'm going to draw an arrow from the 6 to the 1. Then I see I have -2, 1. So I'm going to draw an arrow from the -2 to the 1 as well. And then I have a 5, 8. So I'm going to draw an arrow from the 5 to the 8. Things to notice about mapping diagrams. First thing, notice how in a table you can repeat the y values or you can repeat the x values in a table. But in a mapping diagram, you never repeat these x's and you never repeat the y's. You never repeat the x's and you never repeat the y's. So if you see a number listed more than once, whether it's a y value or an x value, do not list it twice, okay? So it would have been wrong if I had put an extra 1 there. That is incorrect, okay? Here on the next one, I'm gonna again draw a line from -3 to 1, from 2 to 6, from -9 to 17, from -9 to 0, and from 3 to 10. All right, so for the same reason, this first one would be a yes. because my x values do not repeat, obviously, right? We have the same data, so it's going to be the same answer. Here in the second one, this would be a no, because again, you can see that the data repeats, right? You can see I have two negative 9s, negative 917 and negative 90, so that would not be a function there, all right? So that might take some practice. That's not something we typically see as much, but being able to recognize when it is a function or when it's not a function. And then the other thing we can do for graphing is use something called the vertical line test. The vertical line test is going to tell us whether or not a graph represents a function. So if you can draw a vertical line anywhere on the graph, so on the left, in the middle, on the right, no matter where you draw it, if it touches more than once, then it is not a function. Okay, if it touches more than once, then it's not a function. So let's go ahead and try this. On the first one, I could draw a line on the left side, I could draw a line over here, I could draw a line on the right side. Notice it doesn't matter where I draw this line, it crosses the purple once here, once here, once here. No matter where I draw this vertical line, it's only going to cross the purple one time. So this is going to be a function, and it is a function. I'm going to shade in the graph green to show us that it is going to be a function. All right, so green means function. And then the second one I do, again, no matter where I draw this vertical line, if I draw it over here, if I draw it right down the middle, it doesn't matter, right? Crosses the green once there, crosses the green once there, crosses the green once there. There's no way I can draw a line that would cross twice. Therefore, this is a function. Oops. All right, so that's also a yes. The third one, well, if I draw a line over here, it crosses once, true, but if I draw a line over here, we can see that it does cross 2 times, all right? So this would not be a function, and therefore we can say that no, it's not a function. So let's color that one in red. That's not a function because that vertical line crosses twice. This one down here, again, no matter where I draw a vertical line, anywhere I draw it, it would only cross 1 time. So this would be a yes. Oops, wrong color. There we go. This would be a yes. And then the last one with the circle, well, I can see that I can draw a line over here, and we can see it would cross 1, 2 times, which is not allowed, so this would not be a function. All right, so we can use the vertical line test, and that will clearly tell us whether something is a function if it only crosses once, or if it is not a function if it